Okay, let's talk about what you can observe, and hopefully, you'll be surprised when you think about it that there are so many things that you can take a look at just with your eyes. No need for binoculars or cameras or anything else. So, what can you see? You can see the stars, constellations, and asterisms. You can observe the moon and eclipses. There are some planets, in fact, most of the solar system planets we can see. There are meteors, comets, man made satellites, aurorae, Milky Way, nebulae, and galaxies. So, before we delve into each of those, let's just set our expectations as to what we can see with the naked eye. So, we are used to seeing beautiful images from the Hubble Space Telescope and now the James Webb Space Telescope, and also a plethora of images taken from people's back gardens with DSLR cameras and even camera phones now, along with those taken with specific affordable astro cameras and telescopes. So it can be a little difficult to guess what you should be able to see. So let's take a look at some objects that you might be able to see with the naked eye and the difference between what you can see with optical aids and what you can see on your own. So the top row is the Milky Way. So the very first image is a gorgeous landscape astrophotography image of the Milky Way. And what they've done is they've stacked multiple pictures on top of each other to really make that Milky Way obvious. So if you were in clear, pristine skies with amazing weather and almost no light pollution, you would probably see something closer to that second image. And if you're in a light polluted area on a good night, you will see something closer to that third image in the really bluish one. And sometimes I'm looking where I know the Milky Way should be, and I think I can see it, but in all honesty, I probably can't. I'm in a Bortle 5 sky. But that's just giving me an idea where to place my expectations. The next row down, we have the Running Man and Orion Nebula. So, if you've got the constellation of Orion and you've got the sword, in the northern hemisphere, it's the top and middle supposed star that you can see, and from the southern hemisphere, it's the middle and bottom because, of course, it'll appear to be the other way around. So, these aren't stars, they are beautiful nebulae. And the Orion Nebula is a famous star forming region, and they are both absolutely beautiful in the image you can see on the left. But in reality, even in beautiful, clear, pristine skies, what you will see with the naked eye is the constellation of Orion against a background of stars, and maybe the Orion Nebula will be that little bit bigger than the rest of the stars in the sword, but it's not going to be what you see on those images. And then the next row is also taken from Orion, and this is where people have used a hydrogen alpha filter and had their cameras modified to allow in that wavelength of light. So you can see these emission nebulae. These are clouds of dust that are glowing at that particular wavelength and giving off light at that wavelength. So you can't really see it with the naked eye. But if you're looking up in a relatively clear sky in an urban area, you're more likely to see the Orion constellation in the detail you can see in the photo next to it. On the bottom row, I have an image of the Andromeda Galaxy. This is a galaxy that will collide with us in about 5 billion years to make Milkdromeda. And again, it's a very famous galaxy that a lot of people talk about seeing with the naked eye. And again, in beautiful, pristine skies, you're going to see something like the picture next to it. Where I am, it is kind of a fuzzy blob that I can just about make out, and that's only because I know exactly where I'm looking to find it. The next one to think about is planets. So, a lot of people are expecting to see Saturn with its beautiful rings, or Jupiter with its bands and its red spot, and maybe bigger Galilean moons. Now, the Galilean moons should theoretically be visible to the naked eye, but they're so close to Jupiter, it's really hard to make them out. So, what you will see instead, if you look at that Milky Way photo next to it, that brightest star is actually Jupiter. So, that's what you're going to see. You're just going to see what looks like a brighter star. And some, like Mars, will obviously have a more reddish tinge to it. Um, but the other giveaway that they're planets is the fact that their position across the sky changes. So if you were to look at one planet night after night after night, maybe after a month, you're going to really start noticing that it's been appearing in a different place in the sky compared to the stars, which are static in comparison. So, now that we set our expectations, let's talk about what we can see. So, the most obvious ones, the stars, the constellations, and asterisms. What you see in the sky will change depend on your latitude and the time of year. So, most of you probably have heard of star signs. These are based on the zodiac signs in the belts going around the sun or roughly around the equator. And these are groups of stars that we've grouped together and given them a name, and it's just the brightest stars in those areas of sky. And usually the ancients came up with stories as to how they got there. So a lot of the northern hemisphere constellations, we use the Greek myths, but different cultures have different stories for how they got there. So one of the apps that I use, you can actually change the cultural settings, and it'll give you the stories and the names of the constellations as different people around the world have called them throughout time, which is quite interesting. Something else to bear in mind, just because these are the brightest stars that we can see and we can group them together, that doesn't mean that they are anywhere near each other. In fact, the three stars of Orion's belt are further away from us if you were to go backwards and sort of through the constellation than the height of Orion's shoulders and feet. So it's worth bearing in mind, just because they look bright and they look clustered together to us, they may have absolutely nothing to do with each other. They may not be even like part of the same patch of sky at all. It's just the way they appear to us. It's a 3D map on a 2D constellation. So the next thing to bear in mind are asterisms. So asterisms are smaller numbers of stars that we cluster together. So a famous one is the Summer Triangle. So that is one star from the Cygnus constellation, one star from another constellation, and one star from another constellation. So that is Deneb, Vega, and Altair. And they make this large triangle in the sky. Now, that's really easy to spot. However, once you're familiar with which stars they are, you can say, look at Deneb and then start picking out the stars of Cygnus. Or you can look at Vega and then start looking for the stars of the Lyra constellation. Another famous asterism is the Plough, which is part of Ursa Major. We've also got lots of other various asterisms that people spot. So, depending where you are in the world, you will get different asterisms to look for. So, how to know what stars to look for and when? Because, as I said, it changes throughout the year, which is why people have different zodiac signs if they follow astrology. So, first of all, the easiest way to do this is to buy or purchase a night sky guide or almanac or a phone app that will have the stars above you. I highly recommend this for beginners because when you start out, it can be really overwhelming trying to look for everything. And then you think about looking for stars only, and those annual night sky guides will give you comets and eclipses and all sorts of other things to look for. So it can be really great for planning your astronomy. Um, the next thing you can do once you've done this for a couple of months with a night sky guide is potentially buy astronomy magazines with star charts or find an online star chart for whether you're in the northern hemisphere, the southern hemisphere, or the equatorial region. And this is something then that you can start planning, or maybe you can use a planisphere, and you can start using these to start planning what you think you're going to see and look for those. The most difficult level of this is using star chart books and atlases yourself. So you buy an atlas and then you do all the calculations for what you think you should be able to see at that time and date. Now, obviously, more experienced astronomers do that, but I really think start easy and work your way up. You will get there much faster. So let's just vaguely talk about star charts because you will see them in all the books and magazines. You will see a circle, and a bit confusingly, you will see east and west differently to how you expect to see them. So, what it is, it's a representation of what the sky should look like over your head. And that big circle is the horizon line, and you will see the Milky Way, usually that sort of blurry line going through. So you can see it going in a slight arc across the top half of that circle. So if you had this chart printed out, you'd put it above your head, you would align north with north and south with south, and then the other directions will fall into place. The larger stars on this chart are the brightest stars in the sky. It doesn't mean that they're necessarily bigger, they're just brighter and easier to see. So you can start looking for the more obvious ones. And some of the charts that you get in the night sky guides and in magazines will always also put in other things like planetary movements across that chart in the month, um, where the radiant or origin point of various meteor showers will happen, and other interesting things as well to look out for. But that's the very basics you need to be able to read a star chart. The next thing to think about is the moon, the second brightest object in the sky after the sun. It's Earth's natural satellite, and it's also a fossil. It hasn't changed for millennia, except for where we've landed on it and put stuff on it. So it's a really interesting object because it tells us a lot about the theory of the formation of the Earth. So it's very interesting for a number of reasons. It's also a bit of a love hate object because whilst it is so fascinating and it can tell us so much about the Earth and it looks gorgeous and it's beautiful to observe in its own right, it's also so bright that it obscures everything around it. So it does annoy astronomers by being so bright and it obscures the fainter objects in the sky. So, for that reason, some people will either deliberately choose to view the moon or they will choose to view the night sky when it's a dark moon or a new moon or that week of a few days either side. So, if you're looking for a particularly faint object that you're struggling to see, you want a super clear night in the darkest area you can find when the moon is new or a few days either side of that. That doesn't mean you can't find fainter objects when the moon is out. You can, it's just harder. It's also really interesting because the same side of the moon is facing us all the time, which is called tidally locked. So the moon is tidally locked to the Earth. However, because of its wobble or libration, we get to see slightly more than half of it, which is pretty cool. We also get to see different phases of it, and I love seeing where the terminator, that line between light and dark on the moon, is because you start to see little surface features along that line that you couldn't see when it was a full moon. So that makes it super interesting to look at because every night is a slightly different moon. And then on top of that, it has its effect on the tides, and it also we have eclipses as well, which is the movement of the moon and the sun and the earth relative to each other. So, speaking of eclipses, we have two main types of eclipse. We have a solar eclipse, which is where the moon partially or completely blocks the sun from the earth. These must only be observed with appropriate safety precautions, such as eclipse glasses that are made properly or special solar filters. This is really important. Your sunglasses will not be good enough, it can burn the retina of your eyes, and the same with any kind of telescope you have, it can be damaged, or the sensor of a camera can be damaged if you don't have the appropriate filter. So be super careful. If you have the choice of a filter, say a telescope filter or a visual filter, pick the visual filter because that's the one that's going to protect your eyes the most. So, with that said, these are really fascinating events. Even partial eclipses viewed through eclipse glasses, you get to see what is a burning ball of gas in the sky being partially covered by a floating rock in the sky, and it is mind blowing and it really is something special to watch. Obviously, eclipses you can see far out in advance when they're going to occur if you use various different softwares, or even if you just use various different eclipse finding websites, and they will show you the path of the eclipse. You can even plan in advance to go to the places where there will be a full solar eclipse. I will recommend booking them early because they do tend to get very busy. The next thing is the lunar eclipses, which is where the Earth passes in between the sun and the moon appears red or orange. And the reason for that is really fascinating. So, you've probably all seen light go into a prism and split into a rainbow. Now, in this case, the Earth's atmosphere is the prism. So, the blue light at one end of the rainbow is bent the most, and the red light is bent the least. So, you get this sort of rainbow cone going outwards from the Earth, and the moon passes into the reddy orange area of that, which is why it looks either red or orange. So, it's a pretty amazing event to see. I'm sure most of you have seen it at some point where you've looked at the moon and thought, oh, that's an interesting color. Again, you can take a look at when these are going to occur and deliberately observe them. So, we mentioned planets. They appear as point sources of light, like stars but brighter. They move very quickly across the sky compared to stars, so they don't appear in star atlases because they could be anywhere within those star atlases as long as they are within the ecliptic plane, and the ecliptic is the apparent path that the sun takes across the sky. Now, planets have some really interesting movements because we are watching them from our perspective on the Earth, which is also going around the sun. So, if you imagine that you are on Earth, which we are, imagine we're staying still and the sun is in front of us, and now we have a planet, just one, that's going around the sun in front of us, between us and the sun. So, say it's going around the sun clockwise. Imagine it's at the most outer point to the right, and you're going to see it essentially move across the sky to the left as it reaches the other extreme of its orbit. And that's going to move in front of the sun. It's then going to do that sort of loop around the side that we can't see. So it'll appear to stay a little bit still, and then it'll appear to be going from left to right and go behind the sun. So that is what we call a retrograde motion. The planets are not going backwards and forwards, they are going round their orbits. But from our perspective, we just see it go left to right, right to left. They'll go in front of the sun, they'll go behind the sun, and they can have different movements in comparison to other bodies. So, for example, recently Mars was occulted by the moon, which meant that Mars went behind the moon. We also have things like conjunctions where you get two planets really close to each other in the sky, such as a couple of years ago, we had the great conjunction of Saturn and Jupiter. And that was quite special to see, even though they were just 2 point sources of light on the horizon. So, again, using annual sky guides and monthly magazines will help you find them. And eventually, when you are more confident and you start using your own planning software, you will start being able to see when these occur as well. So, which planets can you see? Well, Mercury to Saturn can be visible to the naked eye, depending on the conditions and where they are. So, sometimes if they're low on the horizon, you might not see them. Sometimes, depending where you are on the Earth will depend on whether you can see them or not at certain times of year, just due to the axial tilt, etc. The one that is a bit 50-50, Uranus, you can see if you've got good eyesight in very good conditions in very clear skies. However, a lot of people won't be able to see it, and Neptune you definitely can't see with the naked eye. Next, let's talk about meteors. So, meteors, uh, we get meteor showers appearing with regularity each year as the Earth passes through space debris in its orbit. So, it might have been a bigger meteor or a comet that got broken up, or maybe a planetesimal that got broken up in the formation of the solar system when there was a lot of bombardment. And what's left are these smaller rocks. And as they enter our atmosphere, they heat up and they glow. And when you spot them, you will see what looks like a bright streak or a line appear for not even a second. And they're known as shooting stars. So as we pass through these sort of clouds of rocks, we start off with just seeing a few and then more and more increase until we hit the maximum, which is when they're at their peak and we see the most per hour. And then as we pass further through, there will be less and less until we've left that region of sky. So we use the maximum to describe their peak, and that's when you're going to see the most of them, again in clear skies and less light polluted skies. And there are many different regular meteor showers throughout the month. Now, obviously, there is the potential for more space debris in the future, so other meteor showers could occur in the future as well. You will start to get a feel for when these are if you're regularly out stargazing, and you'll know which ones are available at what time of year. Um, if you are looking to observe them, find out where the radiant is and then turn away from it, and you will see more that way. So, next, let's talk about comets. So, comets are objects from the outer solar system falling in towards the sun with highly eccentric orbits, and they have bright tails of dust and gas that we can see. Some of them are visible to the naked eye, and some of them are not so visible to the naked eye. And some will visit every few decades, and some much longer, coming every few centuries or maybe even millennia. And some we may not have discovered yet because we're not going to see them for another few thousand years. So there are many comets yet to be discovered that we may or may not ever know about. And the best way to keep up with these is to look at sky guides and various space news to find out where and when they're occurring, because some are not ones that we know about and we only find out about them last minute. So, the next thing we can think about is artificial satellites. This can include the International Space Station, which is visible on a good clear night. We also have satellites that enable us to have GPS, weather, and TV, as well as mobile phone satellite companies and internet satellites such as Starlink. So these satellites, the ones that are visible, will look like a star, but it's moving across the sky. So you don't get that line. It will be a point source that you can see moving across the sky. And when trains of them are launched, like with Starlink, you can literally see all these dots in a line moving across the sky. Now, again, there are some issues with astronomers, how they feel about them versus the benefits. So, obviously, there are multiple benefits to GPS, weather, and TV and communication satellites. No one is disputing that. However, they do get in the way of astronomical observations. And whilst you could argue, yes, we should have more space telescopes, those are very expensive and they are one and done. So a lot of science is now being questionable whether it can be done or whether it's achievable if certain amounts of the sky are interrupted during the observing run. And whilst you may not think astronomy isn't, a big thing like medical technology or weather technology that can directly improve lives, there are hundreds of different applications of technology that we use every day and that have come from astronomy, such as the internet in the form it's in, smaller computers, storing and transferring data. All these things that we use in our everyday lives have come from astronomy and space technology. So there are pros and there are cons, and I'm hoping that some kind of happy medium can be found. So they can be really interesting to find, especially if it's the ISS, because you've got something that's the size of a football field going around the Earth at what is essentially a crazy speed, doing different science experiments with people on board. It's mind blowing to think about. You can look up on the internet where it should be at different times. Something else to look at in the sky is the aurora or aurorae. So we've got two sets of aurorae. We've got the aurora borealis and the aurora australis in the northern and southern hemispheres. And these are two bands that are approximately 60 to 70 degrees north and south of the equator. And what's happening is various different molecules in the atmosphere are interacting with particles from the sun, and they get excited, and then they drop back down to their original energy state. And as they do this, they give off a glow. So the two main chemicals in the atmosphere that do this are oxygen and nitrogen, which is why we see the green and red colors. And they are beautiful to see. So they're related to solar magnetic activity. So if you look for solar maximums, which happen every 11 years or so, you will see that there is an increase in sunspots, there is an increase in solar storms, and there is an increase in the intensity and frequency of aurorae. And they are beautiful to see. I've seen them once in Iceland, and the one that I saw was a bluish white, which was an interesting but beautiful color combination to see. We have the Milky Way, which in clear skies and decent eyesight you can see, but you do need to go to a dark site. Those of you in the southern hemisphere will get a beautiful arch, and there are different parts of the Milky Way available to view at different times of the year depending on your location, so do look it up. Interestingly, there was a power cut in California in the 90s, and for the first time, the Milky Way was visible in the sky, and emergency services had a ton of calls coming in from people that didn't know what it was. So they weren't sure if it was an alien invasion or the start of a nuclear war. And actually, it was just the Milky Way. And it's really sad that so many people didn't know it was there and didn't know what it should look like. So I really hope that people get to view the Milky Way at some point in their lifetime. And then something else as well, we've got nebulae and galaxies. So I've mentioned the Orion Nebulae, I've mentioned the Andromeda Galaxy. The Andromeda Galaxy is in the northern hemisphere, and you can trace a straight line from the Cassiopeia constellation to the Andromeda constellation and look where it is. I've mentioned that the middle star of Orion's sword is a nebulae, and Barnard's Loop, the red arc to the right of that, is sometimes visible as a blur. However, in the southern hemisphere, you also have the Large and Small Magellanic Clouds, which are two dwarf galaxies, and they are quite something to behold. So you can see this is a really beautiful bonus picture. You've got the sweeping arc of the Milky Way. Then underneath that, that larger blob is the Large Magellanic Cloud. The smaller blob to the bottom left of that is the Small Magellanic Cloud. And then you've got an aurora to finish it all off. So, what a beautiful photo. So, in summary, we have covered the many objects and events that you can observe, as well as the different realistic expectations about what you are likely to see with the naked eye in the sky. And I hope that's whetted your appetite and given you ideas for the different things that you can observe. It's not just stars, it's not just planets, it's not just the moon. There are so many things, and I hope you get excited about them as I do.